All right, let's talk about a boat that can actually drive itself. And no, this isn't some high-tech billion-dollar project from a giant corporation. What we're diving into today is the amazing story of a boat that was born from one man's 10-year hobby.
So it really makes you wonder, right? I mean, can a small boat actually think for itself out there in some of the busiest waters on the planet? We're so used to hearing about self-driving cars, but a boat? Can it really, make its own calls, dodge massive ships, and handle the total chaos of a port all by itself?
Well, the answer is a big, emphatic yes. It's not just possible, it's already happening. In Japan, there's a boat doing exactly that, right now. And trust me, the story of how this thing came to be is every bit as incredible as the technology.
Okay, so let's get into the 10-year hobby project. This is where we really get to the human story behind the machine. Forget sterile labs and huge teams of engineers. This was born from one person's passion, right out there on the water. Man, this timeline really shows you the sheer dedication, doesn't it? I mean, look at this. It kicks off back in 2015 on just a standard Yamaha boat. A year in, he gets basic engine and rudder control working. Fast forward to 2021, and boom, it's got radar-based collision avoidance. Then, get this, by 2025, the whole system is refined and running on a cheap little Raspberry Pi 5. We're talking about a tiny, affordable computer. It's just an amazing story of patient, step-by-step innovation. And this quote, this really says it all, doesn't it? A self-funded passion and a solitary hobby pursued alongside my fishing trips. I mean, wow. This wasn't some corporate venture. It was literally a hobby he worked on while he was out fishing. It's a passion project in the purest sense of the word. So, who's the person behind all this? His name is Yohei Matsumoto. And his day job? He's a university researcher. But in his spare time, he basically became the architect of one of the most advanced private autonomous boat systems on the entire planet. Incredible. Okay, so how did he pull this off? How in the world do you give a boat a brain? Let's dive into the tech and break down how this whole thing works. So what can this thing actually do? Well, it's fully autonomous, from the moment it leaves the dock to the moment it returns. And this isn't a lab experiment. It's been field-proven in some seriously dense traffic. What's really mind-blowing is that it's all built with affordable, off-the-shelf parts. It just intelligently integrates data from things you'd find on many boats already: radar, AIS, and GPS. The real magic, the secret sauce, is a concept called sensor fusion. And it's actually pretty easy to understand. Just think about how you use your eyes and your ears at the same time to get a better sense of what's around you. That's exactly what the boat does. Its brain takes all the data from the radar, the AIS, and the GPS, and it fuses it all together. This creates one super complete 360-degree picture of its surroundings that's way, way more reliable than any single sensor could ever be on its own. And here's how it all comes together. It's a really elegant little loop. Step 1, sense. The boat uses all its sensors to gather data. Step 2, think. That little Raspberry Pi crunches the numbers, figures out what's going on, and plans a safe path. And finally, step 3, act. It sends the commands to the rudder and the engine. Sense, think, act. It's a beautiful, simple process. Okay, and you're not going to believe this part. The cost. The core computer hardware that makes this all possible, that Raspberry Pi we talked about, we're talking maybe $200. $200! This isn't just a technological masterpiece, it's an accessible one. That's a huge deal. All right, so the tech sounds amazing on paper, but the real question is, how does it hold up in the wild, in crowded, chaotic waters? Well, this is where things get really, really interesting. We're about to look at 4 real-world trials that push this system to its absolute limits. First up, challenge number 1, the distant vessel. Now, this is a scenario that, if you were on the boat, you probably wouldn't even notice. Just a far-off boat in open water. So how does the system handle a basic, everyday encounter? Well, this is where you see the system's real genius. It's all about subtlety. It doesn't slam on the brakes or make a dramatic turn at the last second. Nope. It plans ahead. It makes a tiny, almost unnoticeable course adjustment way in advance, so a big maneuver is never even needed. It's kind of profound, right? The smartest moves are often the quietest ones. Okay, let's ramp up the difficulty. Challenge number 2, the tugboat. We're talking about a big tug kicking up a heavy wake right in a tight port entrance. The stakes are way higher here.
And this is where that sensor fusion really shines. The system grabs the super precise AIS data coming from the tug and blends it with its own radar. And because it has that complete picture, it can confidently execute a safe, close pass. This is a move that would take serious concentration from a human captain. And the boat just does it, flawlessly.
All right, on to challenge 3, the fishing boat. This is a classic harbor mess. You know the type. You've got a faster boat zipping up from behind you in a pretty congested area. So what's the plan?
And this is just brilliant. It shows the system's adaptive intelligence. It doesn't try to outrun the other boat or get into some weird jockeying for position. It makes the smart play. It actually waits, lets the faster boat go by, and then it smoothly speeds up and tucks right into its wake. See, it's not just dodging obstacles, it's interacting with the traffic around it. That's a whole other level.
And now for the final boss. Challenge number 4, the pushed barge. This might be the toughest test of all. Why? Because these barges have a really weird, boxy shape, which can totally confuse a radar system. It makes it super hard to get a solid lock on exactly where it is and which way it's going. And this is where you can almost see the gears turning. The wonky radar data makes the system hesitate momentarily. That little pause is everything. It's not a glitch, it's the system realizing something's off, reevaluating the conflicting data, and then calculating a brand new, safer path. That's not just running code, that is real-time problem solving. So, after 10 years of tinkering, testing, and countless hours on the water, what started as a passion project has become something much, much more. This isn't just an experiment anymore. It's a truly practical, mature system. So let's just take stock of where things are. What we have here is a field-proven system that's hit a really reliable level of performance. And there are hours of unedited video to back that up. One of the coolest parts is that it's designed so you can retrofit it onto older boats. Now, is it perfect? Not quite. It still needs a human to jump in maybe once every few days. But for a one-man hobby project, the progress is just staggering. You know, this whole project really feels like a glimpse into the future of smart boats. It proves that this kind of powerful autonomous tech doesn't have to belong only to mega corporations. But it also makes you wonder, what's next? And what's holding us back? And that brings us to a really interesting final thought from Matsumoto himself. He points out that marine AI is actually way behind the auto industry. And the main reason? There just isn't a giant pool of data for these systems to learn from, like there is for cars. So that leaves us with the big question. What's it going to take to close that gap? And what's needed to get this kind of incredible technology onto every boat out there on the water?